All right, so today we're going to be talking about Chapter 10, Lesson 8. This is about probability of compound events. So a compound event that's when two or more simple events happen. So, for example, it could be something along the lines of flipping a coin, rolling a number cube, getting a heads, and then a 4. That would be a compound event. There are some ways that we can actually look at how many different types of outcomes we could have, and then what the probability of actually getting that favorable outcome that we're looking for. And one of them is called a tree diagram. So a tree diagram looks kind of like a tree, but what it does is it takes into account the different types of activities. So for example, if we flipped a coin and then rolled a die, we would have heads and tails. And then you'd have 1, 2, 3, 4, 5, and 6. And then the last one would be the sample space. So this is the sample. So you could have heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, and then with tails as well. So you can have many different types of outcomes, but using a tree diagram can help you figure out how many outcomes you could have. And then looking at the probability, you can use that to figure out how many favorable outcomes there actually are. So let's look at example 1 here. It says a greeting card maker offers 3 birthday greetings in 4 different colors, as shown below. How many different cards can be made from 3 greetings and 4 colors? So there are 3 types of greetings. So we're going to have greetings as funny, traditional, romantic. And then we can have colors as blue, green, orange, and red. And then the next one would be the sample space. So, first one that we would have funny blue. We have funny green, funny orange, and funny red. We could then have traditional funny red. So a traditional blue, traditional green, traditional orange, traditional red. And then the last one would be romantic and red, or romantic and blue, romantic and green, romantic and orange, and then romantic and red. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different ways. Now example 2, it says the student government consists of a president, vice president, and treasurer. The candidates for president are Jackson, Juan, and Megan. For vice president, you have Jackie and Carlos. And for treasurer, you have Lee, Jacob, and Carl. How many different ways are there to choose a president, vice president, and treasurer? So, for president, you have Jackson, you have Juan and Megan. For vice president, you have Jackie and Carlos. And then because I ran out of room, for treasurer, we would have Lee, Jacob, and Carl. So we could have 1, 2, and 3. Jack could be president, Juan could be president, Megan could be president. For each one of those, Jack could have Jackie and Carlos, Juan could have Jackie and Carlos, and Megan could have Jackie and Carlos. So just based off of those three, we now have 1, 2, 3, 4, 5, 6 options. Because Jack could have these two, Juan could have these two, and Megan could have these two. So looking ahead, we could have Jackie and Carlos. We could have Jackie and Carlos. And Megan could have Jackie and Carlos. So now we're up to 6 items. For treasurer, we have Lee, Jacob, and Carl. So if we have Jack and Jackie, she could have Lee, Jacob, or Carlos, or Carl. Same thing here. So we have 3 for each one. So we have 3, 6, 9, 12, 15, 18 different ways. Now, there's a significantly easier way to look at this, and we'll take a look at that in a little bit here. But now that we've figured out how to find the number of total outcomes, let's use that to find the probability of specific outcomes. So the probability of compound events, what you would do is you would find the probability of each simple event first, probability, and then multiply those two together. So, example 3, it says a toy robot moves straight until it hits an obstacle. It then turns either left or right. If it makes 3 turns, what is the probability that all turns are left? Well, the probability of left on turn 1 is 1/2. It can either turn right or left. This is turn 1. On turn 2, the probability of turning left is also 1/2 because it says it doesn't have any dependence on the previous one. And the probability of turn 3 for left would also be 1/2. So the probability of getting all 3 turns to be left would be 1/2 times 1/2 times 1/2, which would be 1/8. So that would be the probability of after 3 turns having them all be left turns. Again, find the probability of each simple event and then multiply them together to get the compound event. Now, I mentioned that there's an easier way to determine the number of outcomes other than using a tree diagram or other than using anything else, really. It's called the fundamental counting principle. So the fundamental counting principle, this gives you how many outcomes there are. This tells you the total outcomes available. And what you do is you multiply all options together. So for example, if we went back to example 1, for greeting you have 3 options, for color you have 4 options. 3 times 4 is 12. And that's how we got 12 different ways. Example 2, for president there were 3 options, vice president there were 2, treasurer there were 3. 3 times 2 is 6, 6 times 3 is 18, and we got 18 different ways. So example 4, Henry rolls a number cube and tosses a coin. What is the probability that he will roll a 3 and toss a heads? First of all, this is the probability of a 3 and the probability of a heads. So what we can do here is we can find out, well, what's the probability of landing a 3? Well, that'd be 1 out of 6. Probability of landing on a heads would be 1/2. If you multiply those two together, we would get 1/12. Another way we can do that is to figure out the total number of outcomes. there are 6 outcomes for tossing a number cube and 2 outcomes for tossing on a coin. So that'll be 12 total outcomes. So the denominator would be 12. And because there's only 1 3 on a number cube and 1 heads on a coin, 1 times 1 would give you 1. And that's another way that we can use the fundamental counting principle to find the probability of a compound event. All right, if anybody has any questions, please let me know. Otherwise, this is the end of Lesson 8.